finally time to make another data structure. Like I said, I really like this portion because it's very easy for me to do because I'm just building something and explaining how I'm building it. So we're making a binary search tree here. It's going to be of elements, right? But we are going to add a little bit of a restriction in. Because binary search trees require us to search stuff and that stuff is required to be in order, we are going to use E extends comparable E, which just simply means it's a binary tree of E's. All the E's are comparable, meaning that they have the compare to method. They implement the compare to method. And they can be compared with each other, right? So E is comparable to, so integers are comparable to integers, strings are comparable to strings, but we're not making it so that you can compare anything to anything that's comparable. So no comparing strings to integers, right? We're just comparing integers to integers, doubles to doubles, and so on and so forth, right? Pretty much anything that can be put in order is comparable. So this really doesn't affect us too much, but it's useful. So we are also going to make ourselves an int. Let's go ahead and do a private int size. Okay. Hold on a second. Okay. Private int size. Just checking the mic. Private int size. Private node e head. Or rather, as we call it here, the root. Oh, we need to make ourselves a private node class. So private static class node e. It should work here just fine, I think. Node e item. And so private e item. And here, rather than, it's going to be similar to a doubly linked list, except we're going to change what we call things. Node e private node left, private node e right. So this is the definition for a node. And each node contains a reference to the item and a reference to the left child and the right child. But it's important to realize that another way to look at that, and sometimes it's the best way to look at that, is that left is not, though I didn't put left child for a reason, because it's both the left child and the root of the left subtree, right? Each node is the root of its own subtree, right? Just like, it is a fairly straightforward concept, but one that should be, hammered home. So left node, this is the left child, but also the root of my left subtree. They're the same thing. And that's all we need. And again, we're just going to make a constructor, or again, just like in linked list, we're going to make a constructor that doesn't really do anything other than take in the item. E-item is equal to this dot item is equal to item. And as you can see, I prefer to use item today rather than data. It doesn't really matter what we call it. Okay. So we've got ourselves set up here.